Good day, everyone. Today, I will be talking about inverse functions. First, what is an inverse function? An inverse function is when the relation is formed when the independent variable is exchanged with the dependent in a given relation. So, remember that inverse functions are functions that reverses another function. And don't forget that the inverse of a function may not always be a function. For example number 1, find the inverse of 2, 0, 3, negative 1, 4, 0, and 5, 4. And our answer will be 0, 2, negative 1, 3, 0 and 4, and 4 and 5. In finding the inverse of a function given an equation, the following steps can be followed. First, replace fx to y. Second, interchange x and y. Third, solve the new y from the equation in step 2. And the last, after solving the equation, denote the inverse as gx. Example number 2. fx equals 8x minus 3. To find its inverse function, first substitute fx with y. If the function that you want to find the inverse of is not already expressed in y equals form, since fx and y both mean the same thing, which is the output of the function, so the equation will be y equals 8x minus 3. Now that you have the functions in y equals form, the next step is to rewrite a new function where you swap the positions of x and y. Now, the equation is x equals 8y minus 3. This new function with the swapped x and y position is the inverse function, but we will still need to solve for y. So, it will be x plus 3 equals 8y. The final step is to rearrange the functions to isolate y. For us to get rid of 8, the number beside y, we need to divide it in each side. So it will be x plus 3 over 8 equals 8y over 8. So that will turn into x plus 3 over 8 equals y. Once y is by itself, the inverse of the function has been found. Always remember to denote the inverse as gx, so the final answer is gx equals x plus 3 over 8. For example number 3, fx equals square root of 9x minus 5, we have to start by substituting y for fx and interchange x and y, just like what we did on example number 2. After that, it will turn into x equals square root of 9y minus 5. Then again, swap the sides of the equation. So it will turn square root of 9y minus 5 equals x. For us to remove the square root, we have to square both sides of the equation to remove it. Now that our square root was removed, it will turn to 9y minus 5 equals x squared. Now, we have to move the constant, which is 5, to the right. For us to get rid of the number beside y, we have to divide both sides of the equation by 9. So our answer will be y equals x squared plus 5 over 9. Lastly, substitute gx for y, and that is the inverse of fx equals square root of 9x minus 5. For example number 4, fx equals 4 plus x over 9. Solve the inverse, start by replacing fx with y, just the same with what we did with number 2 and 3. So the equation will be y equals 4 plus x over 9, x equals 4 plus x over 9. Interchange the variables, or in short, swap the x and y in the function. So it will be x equals 4 plus x over 9, 4 plus x equals x over 9. Swap the sides of the equation. So it will be 4 plus y equals 9x. Then we have to multiply both sides of the equation by 9 to transfer to the other side. So it'll be y equals 9x minus 4. Then move the constant to the right and change its sign. This is the inverse of the function fx equals 4 plus x over 9. For the fifth example, fx equals 2 over 8x. We have to start by substituting y for fx. So it'll be y equals 2 over x equals 2 over 8y, and interchange x and y. So it will be 2 over 8y equals x. Then we have to swap the sides of the equation just like what we did with number 4. So it will be 1 over 4y equals 4x. We have to reduce the fraction and multiply both sides of the equation by 4. So it will be y equals 4x. Then we have to substitute gx for y, and that is our inverse function. So it will be gx equals 4x. And that will be the inverse fraction for fx equals 2 over 8x. Always remember that there is one important step that we cannot miss, and that is verifying your inverse answers by applying the composition of function and checking if the following two statements are true. Show that f of gx equals x squared. Show that g of fx equals x. Substitute the f and g to each other's x, which is the function in inverse, and if the product of both solutions come out as x, then it is an inverse function. For example, solve for the inverse function and check. fx equals 7x minus 4. First, again, we have to substitute fx with y. If the function that you want to find the inverse of is not already expressed in y equals form, since fx and y both mean the same thing, the output of the function. So it will be y equals 7x minus 4. Now that you have the function in y equals form, the next step is to rewrite new function where you swap the position of x and y. So it will be x equals 7, y minus 4. This new function with the swapped x and y position is to inverse function, but we still need to solve for y. So it will be x plus 4 equals 7y. The final step is to rearrange the functions to isolate y. So it will turn to x plus 4 over 7 equals 7y over 7. Now we can eliminate 7. So it will be x plus 4 over 7 equals y. Once y is by itself, the inverse of the function has been found. So it will be gx equals x plus 4, and that is our inverse of the function. As seen in our solution, since the solution f of gx equals g of fx has been proved to be correct, the pair given is inverse. Remember, finding the inverse of a function is easy. Just apply the 4 basic steps. And that would be all. I hope that you have learned something from this video.